Hi to everybody. I'm going to present you the common work which has been done within working group 4, data storage and analysis, led by Diego and myself. I am Alain Franc from Mahé at Bordeaux. We started from the observation that there is a really huge increase in the need of inventories in metabar coding, which are quite flourishing and developing. And there are intensive computing with a diversity of methods, and heuristics have been used quite a lot to shorten the time of computation. And so we ask ourselves two questions. The first one is, do different methods provide the same result on the same data set, which is, I would say, wishable? And what is the impact of the heuristics on the accuracy of the results? And for this, we have set up a numerical experiment with about 50 clean data sets. We insist that data sets should be cleaned by different pre-treatments. We have selected 4 methods which are widely used and well known, at least 3 of them. And we have crossed all the data sets with all the methods to make some comparisons. So the diversity of data set we have selected is depends on markers, on organisms. Some are on other samples, and some other are mock communities. And here is a picture of the diversity of datasets. It is a multi-dimensional scaling on pairwise distances between all reads in one. There are 4 examples among 50, and you can see that the shape is quite different, which shows that the structure of distances and dissimilarities varies a lot between datasets, which is a good starting point for comparing methods. Here is a presentation of the methods we've selected, in fact 4 of them, not 5. So classical methods are vsearch with a command line given us by Douglas. Second is vsearch with a recipe given us by Ester. We have used swarm as well, and yapotu, which is a homemade design pipeline. I will tell you a few words about in the next slide. We have not retained data2 because it is producing only ASVs and not clusters. So this is what is about yapotu. Yapotu is a pipeline linked with high performance computing in order to avoid heuristics as much as possible. So what we have bought is just to compute exactly all pairwise distances with Smith-Waterman algorithms, which is quite costly in time, but it will permit to benchmark heuristics against this exact way of doing things. And after that, we have just used classical and usual unsupervised clustering methods. It doesn't matter exactly what it is about, but it is exactly equivalent to hierarchical clustering with simple linkage methods. And now I'm going to show you a couple of results. We have all the results for all the methods and all the datasets, and only a few have been selected for this short presentation. Here, one red dot represents one sample, and the x-axis is one method, and y-axis is another one. And it is about the number of otus with over 10 reads, and we say 10 group of reads after the replications. On top left, we see that swarm and yapotu are really well correlated, which means the number of reads is quite similar. Top right, swarm and vsearch are not as much correlated, and bottom, vsearch and vsearch, we see that they are correlated with a positive bias for research. Here is something more detailed, which is just a rank size curve. You see on x-axis you have the rank according to the size, and in y-axis you have the logarithm of size, and you have one picture per sample here with one color by methods. And you can see that most of the time, when you see only blue here, it means that the green is concealed behind, and you can see that swarm and yapotu behave very similarly in 4 different examples, and sometimes vsearch and vsearch converge between themselves and with yapotu and swarm, and sometimes not. So we have a diversity of behaviors with yapotu and swarm behaving in the same way. The third example is computing diversity indices according to the partition in otus. And you can see again that yapotu and swarm top left And in fact, 4 of them are well correlated for richness, Cow, Shannon, and PLO evenness. We're quite so we can compute diversity through yapotu or swarm. We have more or less the same result. Whereas if you do it with comparing yapotu and vsearch, there are significantly different results. So it is not as reliable as it has been with swarm and yapotu. And now I will present you an example of very detailed results, which is a sort of contingency table between swarm and yapotu otus, and we have the same for all pairs of methods and for all samples, which is over 400 files that I cannot show you, of course. So I've taken for this station sample the largest yapotu otu, which is over 3,000 reads, and among the 3,000 reads, 2,577 are common with the largest swarm otus, which itself has 2,600 reads. So nearly all of them are in yapotu otu. And then all the remaining reads in this huge yapotu otu belong to entirely to a swarm otu. For example, 240 of them belong to otu 22, which has 240 reads, and all the same for all the other ones. So the result is that swarm otus are nested within yapotu otu, and this still has to be understood, and it has been observed in all our samples. So what can we say of this work? First, that yapotu and swarm really behave in a very close way, whatever the observation, the number of otus, rank subscores, the diversity indices, and even the composition of otus. So yapotu is without heuristics, and swarm is with heuristics. So this strengthens the results of swarm, which are very close to result without heuristics. And on the contrary, vsearch and usearch sometimes converge and sometimes diverge. And it is obvious that, for example, for computing of diversity indices, they do not yield the same result in swarm and yapotu. And this had to be thought about, and we have not really fully understood why. So what are the perspective now? One perspective is to invest in optimization of codes for diminishing the time cost of working with yapotu. And second and third point together means that this is a numerical experiment of comparison between methods on diversity of datasets, and this can be pursued by wider participation of wider number of teams. So we have in mind to provide a web page where behind a couple of datasets, all of those of course, and those that people want to bring to the experiment, and some tools connected to it for running given methods on a given dataset, and to have a sort of community working on improving comparison and benchmarking between methods for auto picking. And thank you for your attention.